We're going to do an example of a hyperboloid of two sheets in this particular problem. We have an equation here, and what I notice in this equation is that every variable is degree 2, but 2 of the variables in the equation have a negative instead of just 1. So that tells me that I have a hyperboloid, but I have a hyperboloid of 2 sheets. And again, this is also a number. If this were 0, that'd be a different equation. So to do that, we want to get this in its standard form. So we need to have, we already have a 1 over here, but we need to rearrange this to have these little squared numbers. So that's the way we would rewrite it. We just write these 1 squared. We don't really have to, but this puts it in the standard form. And this 1/2 squared here is just because that would be like dividing by 1/4 and using algebra rules. So let's sketch what happens in the xy plane. In the xy plane, if we set z equal to 0, we can form that box. Where y goes from -1 to +1, and x goes from -1/2 to +1/2. And since the x is the one with the x is positive, we know that it's going to be a hyperbola that strikes the x-axis. So we draw our asymptotes through the box. We have our strike points. So we have our xy hyperbola. Let's look at the xz plane while we're at it. Well, if I get rid of y, what I notice is the xz hyperbola is exactly the same as the xy hyperbola. All right, so now I have 2 hyperbolas, but I want to look at the yz plane. So I could just say, oh, I'll set x equals 0, see what happens. If I do that, I have an ill-formed equation. There's no value for y or z that would ever make, right? Because if you square that, it's going to be a positive number, so that's negative, positive number, then it applies a negative. So you have negative numbers trying to equal a positive number. It's never going to work. So what we have to do is we have to pick values for x that are non-zero to kind of make this balance out. So let's take the case where x is equal to, I don't know, 1. Let's see, what can we do here? Let's pick values for x such that x is, let's say x is equal to 2. Let's say x is equal to 2. So that's 4 over 1/2 squared minus y squared minus z squared equals 1. So when I multiply that out, what I get is 16 minus y squared minus z squared equals 1. Well, with a little bit of rewriting, what you find is that's y squared minus z squared equals 15, or y squared plus z squared equals 15. Well, that's the equation of a circle. So what that tells me is that the projection, each time for x is equal to 2, or if x were equal to -2, by the way, this would be the same situation, you're going to have circles in the YZ plane. And that circle is going to be determined by x squared. So we can rewrite this as y squared plus z squared equals 4x squared minus 1. So you could think of the radius as the square root of 4x squared minus 1. So whatever x is, that's the radius of that circle. So you're going to have in the YZ plane, you're just going to have circles. As x gets larger, the circles are going to, the radii are going to get larger. So but again, they're not going to hit the origin. So what that tells me is I'm going to have some sort of hyperbolas that come out, but they're never going to touch the origin. So anyway, let's go ahead and sketch some of this stuff. In the xy plane, again, we've got hyperbolas, so let's and y goes from -1 to +1, x goes to that half mark. And so you have the xy hyperbola that looks like that, and you also have the xz hyperbola that looks like that. And so the x value will actually remain the same here, and the z value will be 1. So if you think about that same idea of that same box, these are going to touch because, well, they're not going to touch exactly, but you're going to have these two hyperbolas that are coming out. And then in the YZ plane, in this particular plane, you're going to see circles. So it's going to open, it's going to look like circles if you were looking down the YZ plane, and then they're going to open up like hyperbolas otherwise. And I probably should have done this in multiple colors, but the idea is you're going to see circles get larger as this goes out. You're going to see hyperbolas as we go. Now, we haven't talked about shifting on these yet, but the idea is you could shift a little and you get a slightly different hyperbola. So you're going to get a hyperbola with circles. And that's kind of how it comes out. And that's a hyperboloid of 2 sheets.